Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll work on edit distance. So this is one of the most important dynamic programming problems. So the problem states that we are given two strings and we need to convert one string into another using the minimum number of operations. So the operations allowed are insert, delete or replace. So this problem teaches the core idea of a 2D DP on strings, and once you master this, many advanced problems becomes easy. So for the brute force approach, we will try all the possibilities at every mismatch, insert, delete and replace. So this creates 3 recursive branches at each step. So this will lead to the time complexity of 3 power n since we have 3 options insert, delete and replace at every step. Let's write the code first. Let's return a method maybe called solve, and we will pass this words word1, word2, and word1 dot length, word2 dot length. Now let's implement this method. The return type would be int, which is nothing but the minimum number of operations performed. Solve, we passed word1, word2, which are strings, string word1, string word2, and length, let's say m and n. Better to say w1 and w2 instead of typing word1 and word2 again and again. So yeah, now we will check if this m and n, if m is 0, then obviously we need to return n, and if n is 0, then we need to return m. If w1 dot char at m minus 1, the last one, is equals to w2 dot char at n minus 1, the last one, then we would return solve of w1 and w2, and we will pass the remaining till the remaining length, which is m minus 1 and n minus 1. So this means that if the last characters match, then we will move both the pointers backwards. So otherwise we will try all the 3 operations. So the 3 operations are insert. For insert we will call solve w1, w2, m and n minus 1. Because for inserting we will keep w1 as it is and we will reduce w2, that's why we are passing n minus 1. And for delete, let me copy this. Okay, then the second option we have is we can delete it, and for delete we will reduce w1 and we will keep w2 same. So we will pass w1, w2, m minus 1 and n. And for replace we will reduce both. So we will pass m minus 1 and n minus 1. Now we will take the minimum of all these operations. So we will return the current count plus the minimum of these three. Minimum of insert, and as we can't pass 3 of them at a time, I'm just writing it like this, replace. Yeah, let's run the code. It is accepted, but since we have 3 options at every step, the time complexity would be 3 power n, and we are also recomputing the same subproblems again and again. So this is not a better approach. So let's go for the optimized one using DP. So yeah, so to do that, let's take m and m like we did earlier for the length of the given words, and n word to length. Now we need a DP table of 2D of size m plus 1 and n plus 1. Now let's first initialize this with -1, I0 I less than or equals to m I plus plus, and for j0 j is less than or equals to nj plus plus. dp of I of j will be -1, and then after coming out we will have all -1s. Now we will call a method solve passing word1, word2, m, n, and this dp. Now let's implement this solve method. Obviously the return type is the minimum number of operations, so it is int, and for solve we passed word1 string word2 int m, int n, and int dp. Now here the same code. If m equals to n, then we will return, if m is 0, then we will return n, and if n is 0, then we will return m. And we will first check if the dp is not -1, which means it is already calculated. Of n is not equals to -1, which means it is already calculated, so we will straight away return that value dp of m of n. And now we will check if the last characters char at m -1 is equals to w2 dot char at n -1. If it is, then we will return solve of w1, w2, m -1, n -1, and dp. But before this we should also update the dp with the answer that we got from this call. Alright. Now we have three options. Either we can insert, delete and replace like this. So if you are inserting, we will call solve w1 w2 m n minus 1 and dp. We have seen y in recursion. If you are deleting, we will call w1 w2 m minus 1 n and dp. Here we'll call m minus 1 n minus 1 and dp, and we will return this. But before that, we will update the dp array. Okay, let's run the code. It is accepted. I'll submit it. Okay, it is working. So the time complexity for this would be O of m into n, because we used for and for. But the space complexity would also be O of m into n. So yeah, that is it for today's problem. Once better to dry run this code, and that would help you understand better. That is it for today's problem, and I will see you in the next one.